Hello everyone, and thank you for joining us for today's webinar. We are excited to bring you this overview webinar on etapAPP, a tablet application for field data collection and synchronization. etapAPP is a free field data collection app that allows you to synchronize ETAP electrical power system software data to view, create, edit, and share ETAP one-line diagrams and engineering data across desktop and mobile devices anytime, anywhere. So let's get started and learn about this ETAP app that you can use on iOS or Apple devices, Windows on your Windows tablet like Surface Books, and Android-based tablets. Very quickly, for those of you who are not power engineers, in power engineering, a single line diagram, SLD, is an electrical drawing representing the electrical devices or assets of a power distribution system. The electrical diagram is represented by symbols and describes how these electrical devices are connected and related to each other. Sometimes, a single line diagram of an electrical installation is also referred to as a one-line diagram. A single line provides a fundamental representation or a blueprint of a multi-phase power system. Could be three-phase or single-phase or a combination of both. As the term suggests, a one-line diagram uses a single or a one line to represent multiple phases of an electrical system. Creating a one-line diagram is the first step in preparing a critical response plan, enabling electrical personnel to fully understand the layout and design of the facility's electrical distribution system. Whether a new or an existing facility, the single line diagram is also the roadmap for all future testing, service, and maintenance activities. An electrical digital single line diagram is a single line diagram that has been digitized and includes advanced functionality and awareness of the device's characteristics and its behavior. It goes beyond just simple graphics by being able to adapt to the connection changes, unlike a conventional drawing. A digitized single-line diagram is the foundation of the electrical digital twin that can be leveraged not only to communicate the network connectivity and asset information, but is also the basis for power system analysis from design to operations. Keeping this digital twin up to date and current is very important as part of your digital transformation strategy. And the reason you want to make sure the digital twin and the corresponding single line diagram is up to date is for a variety of reasons. The very first one is to meet compliance or maintain compliance with applicable regulations and standards. So here in the United States, for example, NFPA 70E Article 205.2 mentions a single line diagram where provided for the electrical system shall be maintained in a legible condition and shall be kept current. And therefore you can utilize ETAP software to easily keep this single line diagram up to date and print out the diagrams whenever necessary in order to meet this compliance requirement. The other reason you want to keep the electrical digital twin and the single line diagram current is to ensure safety. An accurate single line diagram further ensures the safety of your personnel. There are two primary considerations, but there are many more. If you're utilizing electrical safety consultants for your electrical system, they will ask for the latest single line diagram to meet OSHA requirements. Therefore, an updated single line diagram becomes the most fundamental material for any facility. Also, based on NFPA 70E, for electrical safety standards at work, several studies, assessments, and evaluations are required. And in order to perform these activities, again, you must have an up-to-date single line diagram. The single line diagram becomes the main resource for any kind of power system study, assessment, and evaluation, making it one of the most crucial safety documents available at the facility. The electrical safety studies and evaluations that we typically utilize the single line diagram for include calculations of short circuit currents, determining selective protection coordination or selectivity, assessing arc flash energy, evaluating the lockout tagouts and the interlocks, and therefore make it a very important document for ensuring safety. The single line diagram also assists in reducing the downtime and minimizing production loss. It eliminates guesswork by using the latest single line diagram to perform what-if studies and to find the optimal strategy for any power system recovery. If the single line diagram is not kept up to date, it is quite complex and requires some level of guesswork to ensure that the what-if scenario that you're analyzing to get out of an unplanned outage is going to be the right decision for your facility. The single line diagram also carries a naming convention developed by each organization to establish consistency across one or multiple sites. This allows personnel who respond to an event to also quickly identify the equipment experiencing the problems. This naming convention is also helpful for preventive maintenance and documenting which specific switchgear, breaker, transformer, or protective relay they need to address. The other reason for keeping the digital twin and the single line diagram up to date is part of your upgrade strategy. If you do not keep your single line diagram up to date on a regular basis, and whenever you need to perform power system studies periodically, the consultants and the electricians and the power system engineers within your organization will go back and recollect the data from the electrical system because they don't know exactly which part of the asset or part of the data within the single line diagram is still in sync with the field devices. And this essentially causes costly rework and stretches or delays the upgrade phase for your electrical system while the data is being recollected and re-entered into the electrical system software. You can also utilize the electrical single line diagram for operations intelligence. So another reason for keeping the digital twin valid is so that you can actually validate the data that you have put into that digital twin or the single line diagram so that you can make the right decisions. Once you have a strong foundation, you can investigate events, their causes, validate before operate for various operations within the electrical system, include automation and understand the impact of that automation, include optimization strategies, and therefore maintain your facilities in a better fashion, having a very strong or solid foundation. An ETAP multidimensional digital twin platform provides that foundation all the way from design to operations. Now you may be wondering, why am I going through the reasons for maintaining or keeping your single line diagram up to date? Well, it leads into the complexity that it takes to maintain this digital twin and the reason why we have the ETAP app. One of the complexities of maintaining this digital twin and keeping it up to date is the data quality and the errors that are introduced when you go out to the field to collect some data and then you have to bring it back and enter it into the ETAP software. There are chances that the data may be misinterpreted or the wrong data is entered into the software due to transcribing errors. Also, this system of going out to the field, collecting data on a piece of paper and bringing it back to put into the ETAP software, it's a non-integrated approach and it's very time consuming and it requires electricians who are used to going out to the field to understand and learn ETAP software. There are also standardization gaps, and that basically implies that the way you're collecting the data, one electrician to another electrician to a third electrician, there are discrepancies in the way that they are collecting data and bringing the information back to you. And this again causes rework or recollection of the data because electrician A may have brought all the information required, but electrician B and C may not have collected the same data in the same format with the same amount of fidelity. It's also quite time consuming because each time you have to go collect data for one substation, there are multiple components within that substation that need to be reevaluated. You have to take the data with you to verify what you have and essentially replace it with the correct data in case relay settings have changed or a new breaker or new cubicle has been included with a new load attached to it. And then of course there's a complexity of repeatability. This is a difficult process, and a lot of people avoid this process because of its time-consuming nature, and it doesn't get repeated as often as it should. And therefore, the one-line diagram starts going out of sync with the actual field data over time. And then it should also be easy to share this data. Whenever you collect this information, it should be also easy to share with other colleagues who are using ETAP software within the organization. So in order to overcome these challenges, we developed etapAPP for field data collection and synchronization with ETAP. So let's take a quick look at the ETAP ecosystem for digitizing your electrical system and creating this digital twin, and of course sharing this information at the same time. Now within ETAP software, you can build the one-line diagram or single-line diagram and enter all the characteristics of the electrical system, including the protection, cable pulling, underground raceway, and many things that go into this digital twin besides the single line diagram. You can import this data using AutoCAD DWG format. You can bidirectionally exchange data with AutoCAD Revit for BIM models. You can exchange data using various flavors of XML, including SIM and CGMES formats. You can also exchange data using Access or Excel, which is very convenient to absorb all that information into ETAP. You can also exchange data with GIS systems or geographic information systems such as ESRI and ArcFM, and use a variety of these sources to import the data and build the single line diagram. You can also build the model or the single line diagram using the templates that we have provided or templates that you may have created over the past few projects. You can utilize auto build to quickly build the one-line diagram, and you can also utilize the standard graphical drag and drop and connect method to build the single line diagram. So any combination of manual, templatized, or import functions can be used to build the single line diagram. Now we share the single line diagram with other applications using NetPM, which is Network Project Management. It's a cloud-based service that allows the data to be sent from ETAP and be published inside the NetPM application. And if you are out in the field with your tablet, you can download this information from NetPM into the etapAPP. And now you're conveniently moving data from ETAP into the etapAPP using NetPM as sort of the satellite hub, the central hub that allows the information to be connected between different devices. In fact, you can also have other clients connected to NetPM who may be other users. And if these users have the appropriate access, they can also retrieve this information into their respective ETAP software or the etapAPP tablet. And you can now begin multitasking. You can now begin collaborating on the electrical model creation and validation. In fact, we also have eProtect, which is the centralized asset management system and fault analysis system that utilizes a web interface to view the electrical information saved within ETAP in a very visual and straightforward manner. And it also connects to the field, retrieves relay settings, stores them, and is able to now exchange that with ETAP. So you're not only exchanging some of the model information and validating it, you can also exchange relay settings, ComTrade waveforms, and use all of that information for analysis. And we encourage you to watch a separate webinar that we've already done on eProtect to learn more about that. Now, the roles are reversed. Whatever information is being broadcasted from ETAP through NetPM to all the other clients that are connected to NetPM, the same information can be sent backwards. So changes made in eProtect, the etapAPP, or other ETAP consoles or workstations are then propagated back to the master, who can continue merging the changes and making sure that all these different parallel tasks that are ongoing, all that information can come together and be put into that one master model. So here's our quick connectivity, and I'll show you how this works within the software. You can have ETAP at your office or home on your workstation, and the typical connection between ETAP to NetPM would be over Wi-Fi, because most of us use Wi-Fi at home. And the NetPM, which is the cloud service, can be on-premise. You can host your own within your IT infrastructure. So it's on-premise or self-hosted, or it could be a cloud service provided by your IT. So that could be either Azure, Amazon, Google, or others. ETAP itself does not host NetPM. So therefore, it is completely under your IT control, and the data privacy and cybersecurity is 100% managed by your IT personnel. And the connection from NetPM to the ETAP app, which is being used on-site or on the field, would then typically happen either Wi-Fi, but more predominantly over 3G, 4G, or 5G networks. So the process is quite straightforward. We want to go ahead and publish our project from ETAP into the cloud service, and then we want to download that ETAP project back into the tablet so that we can easily take this out to the field and update the information. So let's go ahead and see how to do that. So let's go ahead and get started with the example that we're going to use. The first thing we have to do is set up the usernames and passwords. So in order to do that, you have to essentially enter the project as an admin if you haven't already set the usernames and passwords. The default password for your administrator account is in the ETAP help file. So once you essentially log in, you should be able to see the user manager. We can go ahead and enable passwords for all users. And then we can go ahead and add a new user here, which we'll just call etap1, and set a password also for this particular user as well. And confirm the password and click OK. So we essentially have a new user, which is etap1, and we want to give him full control over this particular project. So once we're done with that, we can go ahead and actually log back into the project, and you can use either ETAP authentication or Windows authentication. So this allows you to decide whether you want to save the passwords internally with the ETAP project or use your Active Directory account to log into this ETAP project. So we'll go ahead and log in as etap1 and go ahead and come in as a project manager and editor, which basically means I'm the master for this particular project. And as soon as the project is loaded, the very first thing we should do is register or publish that project. So we can go ahead and register this project to NetPM. And in order to register it, you must already have a DXM or NetPM installation, and you can contact your IT department to essentially set that up for you. I'm going to go ahead and enter a NetPM URL that I'm going to use for this particular project. It may be grayed out or blurred for you, but it's essentially a net address that your IT is going to provide to you to publish this project. And we're now going ahead and registering this example into our DXM or inside our NetPM, and it's been registered for all of these different usernames. And once that is done, we are ready to go ahead and actually publish our project into the Data Exchange Manager or inside NetPM. So we can click on our etapAPP Manager to export a publication to our DXM. So we'll go ahead and create a brand new publication, and in this case we are publishing this to a user that I'm going to use, which is etap1 that I've created, and I'm going to log in myself. The publication can have any extension. We'll just give it some extension that makes sense, and we'll say this is our first publication to our mobile device, and we want to select the complete project, or you can select a part of the project, but we'll go ahead and export all of it to our DXM for mobile purposes. We'll go ahead and make sure we do that. Now, in order to publish, you have to be in edit mode. So we'll go ahead and actually do that very quickly. Switch over to edit mode. And again, just repeat the steps very quickly so you can see the export. Again, the extension can be whatever you'd like it to be. And the description is also optional. So again, this will be our first publication, and we'll go ahead and publish this into our DXM. And you can see that the ETAP software has published this to the DXM server, and we can now go ahead and log into our tablet and see if we can see this particular project. All right, I have zoomed into one part of the system, which is near bus 2C, and we want to essentially understand what's going on with our arc flash. We are running our arc flash study in this case, and when we run the arc flash study, we find out that on bus 10D, the arc flash energy is quite high. It's level D. The energy, instant energy, is 23 calories per centimeter square. The clearing time is almost half a second. So we want to understand what's going on with this protection. So we request somebody to go out on the field and verify some of the protective device data and report back what they find in terms of the information. So either we are sending this data to an electrician, or I could be putting it on my own tablet and taking it with me so I can walk out to the field and verify or validate, for example, relay number 1. And while I'm there, I can also see what's going on bus 2C, because I suspect that there is a load here that's missing that should be there. So let's go ahead and go through our steps very quickly. We can go back to our edit mode, go to our export, create a new publication. So in this case, for this publication, again, I can give it an extension of your choice. And we want to give it some kind of description so you can keep track of it, what you have done here. So here we want to say validate relay 1 setting. And we want to say OK and publish this particular version into the DXM. So it's done. It's published into the DXM server. And let's take a look at our iPad at this point. So as soon as we click refresh, we can see that the new publication is now available with the blue circle. So we can go ahead and select that one and go ahead and download that into our tablet. Since the publication has been downloaded, we can now go ahead and see on this particular bus, which is bus 2C, we can actually see our relay on this particular bus. And this particular relay happens to be relay 1. And you can scroll through and see all the settings associated with that relay, including the Westinghouse CO relay has 1 overcurrent level. You can stretch this out so you can see the 50 pickup, the curve type, the pickup value, and so on. Now let's say we find out that this relay pickup is not 12. It actually happens to be something different. And the relay pickup here happens to be not 12, but 4. So as soon as we type in 4, we can see that that value is quite different than the previous 12. So that's great. We can go ahead and close this panel out. So let's say once we have done our relay setting update, we walk over to another piece of component, which happens to be a sub 10D or bus ID 10D. And we realize that there is a piece of component on this particular bus that's missing. So it's missing from the ETAP model on the ETAP desktop, but I can see it in the field. So I want to go ahead and add that through my tablet application. And I can do that by simply selecting the bus and stretching the bus so I have more room to add the component I want. We can bring up our tool palette and pick the component that you want. So I want to go ahead and take this motor, tap it, and tap it into the diagram. And we want to make a connection between this piece of equipment and the bus. So we can simply move this component here, tap the connection, and connect it to the bus. And once our connection is done, we can go ahead and start entering more information, or you can simply shorten the size of the bus once you're done with it. But let's say I went ahead and added this and I missed a component. I want to add a CT and a relay as well. So I select a CT from my system, drop it into my diagram, and then I can take this, simply drag and drop it, and you notice that it highlights pink in color, very similar to ETAP. So you can just snap it right in. And then we can also bring in our relay, drop it here, and then we want to connect our relay to this particular CT, and you have your connection made. And then if you realize that, no, I want to add one more piece of component here, which happens to be a breaker, you can simply take a breaker, drop it in, and then same thing, just snap it right in, and you have your connection made. So once this particular modification has been done, we can go ahead and save our project. As usual, the save is successful, and we want to go ahead and publish this to our ETAP project itself. So we can click on projects, go ahead and upload a publication. So verified the relay, and we added new motor. So that's essentially our note, and we want to go ahead and upload this change into the NetPM or the Data Exchange Manager. So our change has been successfully loaded. Let's see what it looks like inside ETAP. Now inside ETAP, again, you know the answer. You go to the etapAPP Manager, and we want to go ahead and look at all our imports coming in. So we can see that our last publication is already available, verified relay and added new motor. So I want to merge this change in as soon as this incoming request is processed. You can see ETAP is actually processing it. The merge and sync wizard comes up, and I want to bring in all my additions, all my modifications, and any deletions that I have done, and go ahead and merge it into my ETAP model. So I essentially accept all the changes and merge them in. So as the merge is complete, we can essentially see that we have a new motor with our relay and the breaker, and you can fine tune that a little bit by just adjusting the ETAP online diagram. And if we double click inside the relay, go to the overcurrent page, we can see that our pickup has now changed to 4, which used to be 12. So therefore, if I go ahead and run my ArcFlash assessment again, the first thing that the program is going to complain obviously is I did not plug in all the information about this machine. So I'm going to temporarily put this machine out of service so we can see what impact it has based on the relay settings alone. And we can see that our fault clearing time went down to 0.4 seconds instead of 0.5, and the incident energy went down slightly because of the pickup changing from 12 to 4. So this is another use case when you're performing studies, you run into results that perhaps look strange or don't make sense, and you want them verified. In the process, you find components that you didn't have. You can easily use the tablet application from ETAP, the etapAPP, and synchronize the data from the field to the ETAP project and vice versa at any point in time. And this should become a continuous ongoing activity that you can train your electricians to be proficient at utilizing the tablet application, and periodically just making updates and changes as they walk the field and they identify or uncover new information. So let's take a look at some of the other functionality that exists in the tablet application by itself before we conclude this session. The tablet application actually has a lot of nice functionality that is available to you. You can actually zoom in and see the full screen for the diagram and eliminate all the controls, or come back and see all the different functions associated with the application itself. You can, of course, tap any component, see its properties, collapse the property pane or bring it back. You can also pin the properties based on the ones that you like to see on the top. So as you scroll through or see information regarding this particular object or any other object, for example, if you go ahead and try to find another transformer here, you can see that the rated MVA values are always pinned because that's my preference. So we can simply unpin it or pin the values you want to see, and this makes it easy to collect certain information like positive sequence impedance. When you move over to another transformer, you can see its positive %Z is pinned and available right on top. So that pinning function is quite helpful and handy in case you don't want to search for a particular property. You can also see different layers of the same diagram. In this particular diagram, we actually have a composite network, which happens to be right here, which is called boiler MCC. So you can select it and you can tap on that boiler MCC to open it up and see what's inside. And same way, you can select a particular component, tap it, and see the properties associated with it. And if you want to go back to the main diagram, you can simply go back to example 3. And if you want to dive into another composite network, let's say this one, you can either tap it and go into that composite, or you can simply go based on this list and go to this annex substation or to the MCC auxiliary AB and see the information that exists for that particular composite network. You can also bring in buses, transformers, branches, sources, loads, protected devices, drag and drop them into the diagram. You can also add subnetworks into the diagram and connect them into the electrical network. You're also able to bring in text boxes and drop them in. And when you drop a text box, you can just simply start typing the text that you want. And once you're done with the text, you can also change the fill color and other information associated with that particular text box. And this text box is then also synchronized with the ETAP, especially if you want to make some notes regarding the data that you've collected. You can also tap a particular component. You can see that this happens to be 400 horsepower synchronous machine, and this one also happens to be 400. Let's say if we were to change this to 350 horsepower, and we want to now essentially copy this data and actually go to this machine, which is 400, and paste this information. You can see that this is now 350 as well, just the same as the previous machine. And again, the red border is telling you that's changed from the previous set of data that you had. So you can very easily plug in data for one piece of equipment and paste it as you are collecting data from the field, making it quicker and easier to navigate and get more information. You're also able to attach a picture. So if I select this piece of component and I want to capture a picture or attach an existing picture, you can simply click on capture and capture the image that you want to grab. In this case, click OK. I'm just grabbing a blank picture here for a quick demonstration purpose, and we just want to call it test and give it a tooltip as well. Let's say it's test, and accept it. So we essentially now have this photo saved with this piece of equipment. So you can see the properties for this component, and when you collapse this panel, you can see the photo as well. And this particular photo, you can click on it, see more information about the picture. You can retake it, delete it, rotate it, share it. A lot of different functionality available to you to manage that piece of picture. You can also go ahead and alter the text after you have taken it, so it's not in stone, and that can be changed and then synchronized with the ETAP project on your desktop. Another nice thing about the software is you can select a piece of component, let's say a substation, and you can also click on the location to geotag this particular asset, where we bring up a map and actually geotag it. And again, just for sake of privacy, we have the location access denied. So you can give it a try on your particular application, and it works beautifully well by applying a pin onto the map itself. You can also go inside the settings for the app and customize your application, give it a preference by filling in your name, company information, so we know a little bit more about you and how you use the application. You can also turn on certain features for the app, such as the auto saving every 5 minutes, where you want to save the photos, the quality of the photos. Do you want to see the saved values? Do you want different colors for your alternating rows? And how you want the components, the project list to be sorted. And about the application itself, you can see all the changes that we've made over the past couple of releases. And related to the one-line diagram, you can also change the symbology to ANSI, IC, change the line thicknesses, and a lot of different preferences associated with the one line as well as the GIS itself. Another handy feature is the little search button right here. You can bring it up at any point in time. And when you're looking for a component, let's say relay 1, you can just type in relay, select that, and the program automatically highlights and jumps the one-line diagram to that piece of equipment. If you want to go after relay 2, it keeps that search so you can quickly find relay 2 as well. So it makes it quite handy if you're looking for components that begin with a certain name, let's say a breaker, and you can select CB1 and then similarly select other breakers that have similar names and find them very quickly inside the model. So let's quickly summarize what we have learned so far. You can have ETAP synchronized to the tablet application, which is etapAPP. You can have ETAP in your office or your home workstation. The tablet application is something that you would use on-site or on the field, and the connection could be through Wi-Fi or cellular. And the common glue that joins the two applications together is NetPM or Data Exchange Manager that can be on-premise or self-hosted, or it could be on a cloud provided by your IT providers. The process requires that you set up username and password for your project that you want to distribute to the mobile tablet. Once you set up the username and password, you publish the project to NetPM and then download that project into the etapAPP, ensuring that you have the correct usernames, passwords, and permissions established to essentially push the information into the field. You can then collect the data on the etapAPP, verify data, modify data, add, delete data, and upload that information into NetPM and then merge it back into ETAP. And you can also control what you are merging back or accepting into the ETAP model itself. So with the etapAPP, you can collect, view, and verify data. You can add the nameplate and rating information, capture equipment pictures, link these images to the model by simply putting in the hyperlink descriptions and the tooltips. And you can also use this application in the light mode or essentially the dark mode. And that can essentially be accessed by switching to dark mode within the tablet itself, and the application automatically adapts. You can also use the etapAPP for system modeling and layout, making it very easy to edit the one-line diagram by simply adding new objects or components into the model, selecting the data, an existing piece of data, and pasting it into the new component that you've just created. And then the program quickly shows you what you have changed from the previous state to the new state. So essentially your original data as well as your pasted data. You can also scroll through, look at all the properties that exist for that component and modify them when you're out on the field, allowing you to quickly also navigate through and filter the properties. And these properties are based on your data block templates. So you can also adjust what you are publishing and viewing on the mobile tablet. And you can also utilize the system modeling and layout to include geotagging, view layered system diagrams, and also have automated connector routings. You can also utilize the etapAPP for easy synchronization and security management. You can manage the project access by area or substation. You can also exchange data wirelessly between different users, and you can synchronize with the NetPM collaborative analysis platform, making it easier to exchange information from one location to another. You can also utilize Windows authentication for security purposes. Finally, the etapAPP is available on the iOS App Store, on the Microsoft Windows Store, as well as on Google Play for Android devices. Using the etapAPP is free. It gives you this increased accessibility to the ETAP projects for data collection and verification. And if you are an ETAP user, it's an invaluable tool that you must have connected to ETAP to make sure that your digital twin is synchronized and kept up to date at all times. We will be covering other aspects of the single line diagram as well as NetPM in our subsequent webinars that are coming soon. And we look forward to seeing you in those webinars as well. Thank you very much and have a fantastic day or evening wherever you may be. Thank you.